The universe is usually silent, a graveyard of cold stars and drifting rocks that have followed the same predictable paths for billions of years. We have grown comfortable with this silence. We have mapped the orbits, calculated the trajectories, and written the laws of physics that govern the dark void. But every once in a while, the silence breaks. Something arrives that refuses to follow our rules, something that looks back at us from the abyss and challenges everything we thought we knew about the cosmos. For months, astronomers have been tracking a ghost, a faint streak of light named 3I, the third interstellar object ever discovered. We knew it was fast. We knew it was from another star system. But we thought it was just another rock, perhaps a little strange, but ultimately natural. We were wrong. New images have just emerged from a dark summit in Hawaii that have thrown the scientific community into absolute turmoil. These aren't blurry, ambiguous smudges from a government satellite held back by red tape. These are high-definition, AI-processed captures from an amateur astronomer that show a structure so precise, so geometrically impossible, that it is currently defying standard cometary models. They call it a razor-thin anti-tail, a beam of material projecting directly toward the sun, maintaining a structural integrity that should be impossible against the chaotic forces of the solar wind. Today on Quasix Cosmos, we are going deep into this breaking discovery. We are going to analyze why this impossible structure has mainstream scientists scrambling for answers, and why some researchers are beginning to whisper that we might be looking at something engineered. To understand the gravity of what has just happened, we have to transport ourselves to the dark skies of Hanukkah, Hawaii. While the world's billion-dollar observatories were calibrating their instruments or waiting for committee approval, an amateur observer known as Kalopa Stars pointed a smart telescope, the C-Stars 50, toward the constellation where 3I is currently speeding through the dark. What they captured was not the chaotic, fuzzy cloud we expect from a comet. Usually, when a comet gets close to the sun, it's a messy event. Ice sublimates into gas, dust flies off in all directions, and the solar wind blows it into a ragged, fan-shaped tail. It's a dirty snowball melting in a blast furnace. It's chaotic by definition. But look at the image from Hawaii. Instead of chaos, we see order. We see a sharp, coherent, razor-thin line of material projecting forward, defying the spread we usually see. This is the anti-tail. Now, in standard astronomy, an anti-tail is often dismissed as an optical illusion. It happens when the Earth passes through the comet's orbital plane, allowing us to see the sheet of dust edge on. Imagine looking at a piece of paper from the side. It looks like a thin line. But here is where the story shifts from geometry to mystery. For a dust tail to appear this sharp, this linear, and this persistent, the particles inside it have to be behaving in a way that is statistically incredibly unlikely for a natural object. The leading theory from mainstream astronomers right now is that we are looking at heavy dust. You see, the solar wind is like a constant, invisible hurricane blowing outward from the sun. It easily pushes light, fluffy dust particles away, creating that broad, curved tail we see in comets like Hale, Bopp. But if the particles are heavy, dense grains of metal or rock, they can resist that wind. They lag behind the comet in a straight line. So the argument goes that 3I must be releasing massive amounts of heavy metallic dust. But this explanation, while comforting, opens up a Pandora's box of new questions. If this is natural dust, why is it so uniform? Nature creates distributions. When you smash a rock, you get big chunks, small pebbles, and fine dust. You get a mix. But the sharpness of this line in the Hawaii images suggests that the particles are monodisperse, meaning they are all roughly the same size and mass. This uniformity is what has ignited the fiercest debate we have seen since Oumuamua. Industrial processes create uniform particles. Nature creates messes. The fact that we are seeing such a clean, sorted structure has led researchers like Avi Loeb to suggest that we need to be open to the artificial hypothesis. Could this stable structure be a result of engineering? Could we be looking at a controlled emission designed to maintain the object's orientation? It sounds like science fiction, but when the data refuses to fit the natural models, we have to look at the outliers. The clarity of these new images has moved the discussion from theoretical math on a whiteboard to direct observational analysis. We are no longer asking if the anomaly exists. We are asking what physical mechanism is strong enough to hold this structure together against the violence of our star. Let's dig deeper into the physics of this impossible tail. The persistence of the feature is key. Usually, geometric illusions are transient. As the Earth moves, our viewing angle changes and the illusion fades. The line should widen, blur, and disappear. But the data coming from Hawaii shows that this anti-tail is holding its shape. It's stable. This suggests a continuous, steady ejection of material that remains perfectly aligned with the solar vector. It implies that the nucleus of 3I ATLAS, the solid core hidden inside that cloud, is stable. And that is weird. Small comets like this one is estimated to be usually tumble chaotically. They spin wildly as jets of gas erupt from their surface, pushing them this way and that. But 3I ATLAS seems to be locked in a stable rotation, acting like a flywheel. This stability brings us back to the metal core hypothesis. If the object is a dense chunk of iron or nickel, a shard from the core of a destroyed planet in another solar system, it would have the inertia to keep spinning smoothly. It wouldn't tumble like a fluffy ball of ice. It would cut through the solar system like a bullet. This fits the visual data. It explains the heavy dust, but it paints a violent picture of the object's origin. It means we are looking at the corpse of a dead world, a planetary core that was ripped apart by a cataclysmic collision billions of years ago and flung into the dark. We are effectively sampling the geology of an exoplanet system using a telescope in a backyard in Hawaii. But there is another layer to this mystery, one that borders on the edge of our understanding of physics. Some researchers are looking at the razor-thin quality of the tail and asking, could it be magnetic? Comets don't usually have magnetic fields, but planetary cores do. If 3I ATLAS is a magnetic shard of a dead planet, it could be generating a field that traps the charged dust particles. Imagine invisible magnetic field lines acting like a shepherd, forcing the dust into a tight, straight column, preventing it from spreading out into space. This would create exactly the kind of impossible structure we are seeing, a magnetically confined plasma tail. If this is true, it would be a historical first. We would be witnessing a magnetic interstellar traveler. The implications of this are staggering. It bridges the gap between the natural and artificial camps. It's a natural object, a core, but it has structure through magnetic confinement. It explains the collimation without needing aliens, but it requires us to accept that the universe is capable of throwing magnetized planetary hearts across the galaxy. This hypothesis is currently being tested by scientists who are scrambling to cross-reference the visual data with spectroscopic readings. They are trying to find the chemical fingerprint of the dust. If the spectrum shows iron, nickel, and heavy metals, the metal core theory wins. If it shows silicates or organics, we are back to square one and the mystery deepens. The timing of this discovery could not be more dramatic. We are currently in a critical launch window. 3I ATLAS is approaching its closest point to the Sun, its perihelion, scheduled for December 19, 2025. The heat is increasing every day. The solar wind pressure is quadrupling. This is the ultimate stress test. If the anti-tail is just a fragile collection of dust, the increasing pressure should blow it apart. It should disrupt and fade. But if the tail is magnetically confined, or if it is an engineered structure, it might hold its shape even as it dives into the fire. The next few weeks are the crucible. Astronomers are watching every pixel, waiting to see if the structure buckles or holds. What is truly revolutionary about this moment is who is doing the watching. This discovery wasn't handed down from the ivory towers of academia. It came from the ground up. The Seastar S50 used by the observer in Hawaii is a consumer-grade instrument, a smart telescope that anyone can buy. It represents a democratization of deep space science. In the past, only the giant mirrors of the Keck or Hubble telescopes resolved these kinds of details. Now a global network of amateur trackers is monitoring the object hour by hour, ensuring that no sudden brightening, no shift in trajectory, and no change in that impossible tail goes unrecorded. They are feeding data directly into global tracking databases, refining the orbital parameters in real time. This collective intelligence is crucial because 3I ATLAS is accelerating. There is a slight, non-gravitational acceleration acting on the object, a push that isn't coming from the sun's gravity. For a normal comet, this is easy to explain. Gas jets act like thrusters. But here is the problem: if the tail is made of heavy, slow-moving dust, It shouldn't be generating enough thrust to push the object the way we are seeing. Heavy stuff doesn't make for a good rocket exhaust. So, where is the thrust coming from? Is there an invisible gas jet we aren't seeing? Or is the anti-tail itself related to the propulsion? This disconnect between the visible structure and the measured movement is the smoking gun that keeps the artificial conversation alive. Let's consider the alternative for a moment. Let's look at this through the lens of the technosignature. Hunters, if you were going to design a probe to travel between stars, you wouldn't make it out of ice. You would make it out of metal. You would give it a dense, stable core to survive impacts, and if you needed to stabilize it or communicate, you might emit a controlled stream of material. The uniformity of the particles in the tail, the fact that they look disperse, is exactly what you would expect from an industrial process, not a natural one. Nature is messy, engineering is precise, while the scientific consensus sits at 99% natural. That lingering 1% of uncertainty is being driven entirely by these stubborn structural anomalies that refuse to fit neatly into our textbooks. As we move deeper into December, the viewing angle from Earth is going to shift. We are going to move out of the comet's orbital plane. This is the moment of truth. If the anti-tail is just an optical illusion caused by our viewing angle, it must widen and fade as we move away. Geometry demands it. But if we move out of the plane and that line stays sharp, if it remains a tight, collimated beam pointing at the sun, then the illusion theory collapses. That would be the moment the scientific consensus fractures. That would be the moment we have to accept that we are looking at something physically real, something that is maintaining its shape against the laws of orbital mechanics. The data from Hawaii has provided the baseline. We now have a before picture. The next 2 weeks will give us the after. Every night that the anti-tail remains razor thin adds tension to the models. It forces astronomers to run more complex simulations, to invoke magnetic fields, to consider exotic materials. We are watching the scientific method grind forward in real time, fueled by data from amateur backyards. It is a waiting game played with telescopes. There is also a strange irony in the color. The early analysis suggests the object is bright, with a high albedo, which usually means ice. But the mass requires metal. The hybrid model suggests pebbles of iron encased in ice, a dirty metal snowball formed in the snowline of a distant alien star system. Just think about that concept. We are visually inspecting the geology of a star system light years away. We are seeing the building blocks of a planet that might have existed billions of years before Earth was born. Whether it is a natural shard of a dead world or something more purposeful, it is a messenger. The urgency is palpable. 3i8LAS is not staying. It is on a hyperbolic trajectory, meaning it is hitting the gas pedal and leaving the solar system. It will never return. We have one shot to understand it. NASA and other agencies are using this Hawaii data to calibrate the exposure times for the James Webb Space Telescope. They are using the amateur find as a pathfinder, a guide for the most powerful eye humanity has ever built. They want to capture the spectrum of that tail. They want to know if it's made of silicates, iron, or refined alloys. That spectral reading will be the final verdict. So, where does this leave us? We are standing on the precipice of a major realization. The universe is sending us packages. Oumuamua was the first wake-up call. Borisov was the reassurance. But 3i8LAS is the puzzle. It is the one that doesn't fit. It combines the weirdness of the first with the activity of the second and adds a structure, this razor-thin anti-tail, that is entirely its own. It is a daily reminder that our models of the universe are based on local examples, on the rocks we find in our own backyard. But the galaxy is vast, and it is capable of creating things or hosting things that break those molds. As 3i8LAS dives toward the sun, glowing with its mysterious blue, tinged coma and trailing its impossible tail, it serves as a sharp, bright line drawn across our understanding of the cosmos. The silence has been broken, and the message, whatever it means, is being written in light and dust for anyone with a telescope to see. The only question remains, are we smart enough to read it before it fades back into the dark? The next few weeks will tell the story. Keep your eyes on the data. The truth is about to be revealed by geometry itself.